Hi, welcome back. In today's video, we would like to talk about classes in Python. So what is a class? A class is a blueprint for creating objects. It defines attributes, or let's say variables, and methods, or we can also say functions that objects of that class will have. And what is an object? So an object is an instance of a class. Each object has its own attributes and can perform different actions. Let me illustrate it with an example. Here I have a class called Matplotlib. When we would like to declare a class, we need to write down the keyword class and then the name of it. Then we are going to have the column. After that, we see that in this class Matplotlib, we are defining 4 functions. So 4 functions are included in this class. The first function is add, the second one is subtract, the third one is multiply, and the last one is divide. So this is a class that holds 4 functions, okay? And each function performs different tasks. For example, in the add class, we are going to return x plus y, these two arguments of the function. However, in the third class, for example, we are calculating the x multiplied by y. Okay, so each function performs a different task and all of them are grouped in one class called the Matplotlib. Here, I would like to, for example, call this add function to do some mathematical operation for me. In order to call this add function, I type down the name of the class, then I put a dot here, then I type down the name of the function. So this way I am calling the add function which is inside the Matplotlib class. And inside parentheses, just like always, we are going to have arguments because this function needs 2 arguments, x and y. And 2 arguments are provided in parentheses. Here, in the next line, here I'm calling the subtract function from the Matplotlib class. In order to call this function, again, I type down the name of the class first, then I put a dot, and then I type down subtract. And in parentheses, I am passing 2 arguments as x and y that are required for calling this subtract function. This function is going to calculate x minus y and return its value. And because we are putting the call of this function inside a print function, it is going to print the returned value and the output of this function. Then we are calling the multiply function and we are passing 10 and 5. So 10 and 5s are x and y. So 10 multiplied by 5, the result will be 50. So 50 is returned and we are printing here basically the output of this multiply function, which is 50. So we are printing 50 in the output. Finally, we're calling the divide function. So we type down the name of the class dot the name of the function, and we are having 2 arguments, 10 and 0. And here 10 equals x because 10 is the first argument and the first argument here is x, and then y equals 0. Here we check to see if y equals 0 or not, because it's not possible to divide a number by 0. Therefore, we want to make sure that this is not happening here. So I say if y equals 0, instead of returning any result, return this message: cannot divide by 0. Otherwise, if y is not equal to 0, return x divided by y. So when I run this code, these are the numbers. So 15 is the result of this add function. So 10 plus 5, the result is 15. Then 10 minus 5 for the subtract function, the result is 5. 10 multiplied by 5, the result is 50, is shown here. And then 10 divided by 5, we see that it says cannot divide by 0. So if I change it to, for example, 2, and I run the code one more time, we see the results remain the same except for the last part. 10 plus 5, the result is 15 here shown. Then subtract stays the same, multiplication stays the same because we didn't change them. But when we are having 10 divided by 2, so we call the divide function here, and it checks to see y equals 0 or not. So y is 2, so it's not equal to 0, so this part is not going to be executed. Therefore, it is going to return the value of x divided by y, which is 5. So 5 is returned, and we are basically printing number 5, which is the output of the divide function with these two arguments. So in this video, we learned about classes. Then later on, we're going to also learn about objects and see how we can use objects to call a function, for example, from a class. And here we learned that we can group relevant functions in one class in Python to increase the readability of our code. And we learned how to call a function from a class. Thank you for watching. Hi, welcome back. In today's video, we would like to work with another class example. So we would like to have message printer class that handles printing different messages through different functions. This class contains methods, or let's say functions, to print different types of messages. Here is my class. To declare a class, I use the keyword class and then type down the name of the class, and in this case it's message printer, and then we are having the column. Here are my functions. 3 functions are defined inside this class. So the first function is named greet, and you see that we have no argument for this function. For example, we don't have x and y inside the parentheses. So whenever we want to call this function, we don't have to write any arguments inside the parentheses. We can just call them by their name and empty parentheses. Whenever this function greet is called, this message is shown in the output. Hello, welcome to our program. This is what the greet function is going to do for us. Then we are having another function called farewell. And this function also requires no argument. And whenever this function farewell is called, it is going to print goodbye. Have a great day, message in the output. So whenever the farewell function is called, it is going to print this message in the output. And the last function is called error message. So whenever this function is called, this error message is shown in the output. Error, something went wrong. So this was my class. And in order to call the functions of this class, we learned that we need to type down the name of the class, then we put a dot here, and then we type down the name of the class. For example, for the greet class, we type down the name of the class, which is message printer dot, then we type down the name of the function, which is greet, with empty parentheses because these functions require no arguments. So when we call this function, this message is shown in the output. Then we call the farewell function, and also then we call the error message function. So we expect that in the output, we are going to see this message, then this message, and then this message. So when I run this code, we see that this message is shown. Hello, welcome to our program. Or goodbye, have a great day. And finally, error, something went wrong. So here we learned that, for example, we are having a class called message printer, and inside this class, we defined 3 functions. Each of them are printing a specific and unique type of message. And here, all these three functions are grouped into a message printer class. So it's a good way to increase the readability of our code. Here we learned how to declare a function and how to have different functions inside a class and how to call a function that is inside a class. Thank you for watching. Hi, welcome back. In today's video, we would like to declare and create a class called shape calculator. And in this class, there are three functions that calculate area of different geometric shapes. Here, in order to create my class, I type down the name of the keyword class and then the name of the class and then colon. So the name of my class is shape calculator. Inside this class, I'm having three functions. The first function is the area of a square. And in order to calculate the area of a square, we need to have one of the sizes of that square. And this is the argument of this function. So whenever we call this function, we at least need to have this number inside the parentheses. When we're calling this function, we must have this number inside the parentheses. And basically, this function is going to multiply sides to itself. A side multiplied by itself is going to be the output. It is going to be the output of the area of a square function. Then we are having another function called area of rectangle, and there are two arguments for this function, length and width. So this function is going to return the multiplication of length and width. So length multiplied by width, it is going to be the output of the area of rectangle function. Then we are having a function called area of a circle, and then we are having the radius as the argument of this function. So one number is needed when we are calling this function. And basically, this function is going to multiply 3.1416 by radius to the power of 2. Okay? So whenever this function is called, this calculation is performed. In order to call the area of a square function, we type down the name of the class, we put a dot, and then the name of the function area of a square. Then inside the parentheses, we need to have one argument because this function requires one argument, which is the side size of that square. And we assume that for example, side equals 4 centimeter. So we call this function, and this function is going to multiply 4 by 4 and return its value. So the output is 16, and 16 is now shown here, and we are basically printing the number 16, which is the output of area of a square function from the shape calculator class. Then here I'm calling the area of rectangle function with two numbers, 5 and 3. So 5 multiplied by 3, it is 15, and 15 is returned. So we are printing number 15, which is the output of area of rectangle function from the shape calculator class. Finally, we are calling the area of circle class, and we are passing number 7 to be the radius. Here, this function is going to calculate this formula 3.1416 multiplied by radius to the power of 2. So 7 to the power of 2 is then multiplied by this number, and the output is returned. Okay, and we are going to print the output. So when I run this code, we see that first we are having number 16, which is the result of this function. We could also show a message. For example, here we could have a message, the area of square is. So when I run the code one more time, we have a message, so it's more clear in the output. We can do the same for the rest of the functions as well when we are printing their output. For example, here the 16 comes from this function, area of a square, because this is the first function that is being called. So this is why I say that the first result is for the first function, because this is the first time that we are calling a function in this code. So area of a square, 4 multiplied by 4, so the output is 16. Then the 15 is for this function, length multiplied by width, which is 5 multiplied by 3, so the output is 15. And finally, the area of circle, we see that this number is shown in the output, which is the multiplication of this number by this number. So 7 to the power of 2 is 49, and then 49 is multiplied by this number, and this is the output of that formula, and then output of that formula is returned here, and it is here. So we are printing the output of the area of a circle function from the shape calculator class. Again, here we grouped the relevant functions inside one class to increase the readability of our code. And in this example, we learned how to call a function from a class, and then how to pass arguments and see the output here in the terminal. Thank you for watching. Hi, welcome back. In today's video, we would like to have a class called converter, and inside this class, we're going to have three functions that they are going to convert between different units. So in order to create a class, we use the keyword class, then the name of the class is converter. Then we are going to have the colon. In order to define the functions, we use the def keyword and then the name of the function. So the name of this function is kilometer to miles. So we are going to convert kilometer to miles in this function, and we are going to have one argument to call this function. So basically what this function is going to do is the following. So for example, we want to see 10 kilometers is how much miles, okay? Therefore, this function is calculating this for us. So kilometer multiplied by this number is going to give us the equivalent of 10 kilometers in miles unit. Then we are having another function called Celsius to Fahrenheit. So this function also requires one argument, and we are going to see, for example, the degree 25 degree in Celsius is what temperature in Fahrenheit. Okay, so we are having a temperature in Celsius, for example, it's 25 degrees, and we would like to see the equivalent of 25 degrees in Celsius. We want to see the equivalent of this temperature in Fahrenheit. In order to do that, there is a formula. So this is the formula, and basically we are going to, for example, call this function with number 25, because the temperature, for example, now is 25, and we would like to see, okay, 25 in Celsius is what temperature in Fahrenheit. So that 25 multiplied by 9 divided by 5 in parentheses, and then plus 32 is going to give us the equivalent of Fahrenheit of 25 degrees in Celsius. Okay, so this is what this function is going to do basically. Then we are having kilogram to pounds. So this function is going to calculate, for example, if we are having, for example, 10 kilograms, we would like to see 10 kilograms equals to what in pounds unit. Okay, so what is the equivalent of 10 kilograms in pounds? This function uses this formula to calculate this for us. So whatever that we are going to calculate, for example, we would like to know the equivalent of 10 kilogram in pounds. We are going to call this function with number 10, and 10 is multiplied by 2.20462. Then the output this function is going to return us the output of this calculation. So this is my class. So this is the converter class. We are having kilometer to mileage to miles, let's say, Celsius to Fahrenheit, and kilogram to pounds functions. These are three functions that are going to convert different units for us. Then in order to call this function, we learned that we need to first type down the name of the class, use dot here, then kilometer to miles, and inside parentheses we type down number 10 because we would like to know the equivalent of 10 kilometer in miles. So this function is going to calculate that for us and return the output. And basically, because we are calling this function inside a print function, we are going to print the output. Then we are going to do the same with the Celsius to Fahrenheit function. We would like to know the temperature 25 degrees in Celsius is what temperature in Fahrenheit. What is its equivalent in Fahrenheit, let's say. So we call this function Celsius to Fahrenheit, and we're passing number 25 as the argument, and this function is going to do this calculation and return the output, and we are here printing the output. And finally, we are having the function called kilogram to pounds, and we would like to know, for example, 5 kilograms is equals to, let's say, 5 kilograms equals to what in pounds unit. Okay, so we would like to know the conversion of 5 kilograms in pounds. In order to do that, there is a formula here, so we call this function with number 5 as the argument, then we are going to return the output here. So when I run this code now, we see that the first result is 6.2 approximately, let's say. So 10 kilometers equals to 6.2 miles. Then 25 degrees in Celsius equals 77 degrees in Fahrenheit. And then 5 kilograms equals around 11 pounds. So this is how we grouped three relevant functions for converting between different units in one class called converter, and then one by one we called these functions. Thank you for watching. Hi, welcome back. In today's video, we're going to have a class called text processor, and it is going to perform, there are functions in this class that they are going to perform text related operations. For example, let me illustrate it with an example here. So this is the class called text processor, and there are three functions in this class. In order to create a class, we're going to use the keyword class, then the name of the class, and then the column. We can change the name of the class to whatever we want. We can name it X, we can name it Y, H, whatever we want. But it's preferable to write down a number a name that makes sense so you can remember it easily. For example, when I see this name on my class, for example, text processor, I would say, okay, I understand somehow about the functions that are inside this class. So text processor, okay, I'm having some functions that are doing something related to text. So this is how I choose the name of my class. In the previous videos, for example, you saw that the name of the class was converter because inside of that class, I was having functions that they were converting between different units for me. So you can name this function to be X, but then you need to remember X means what. If you provide a name that means something, it would be nicer because when you're having a very long line code, for example, 2000 lines, and you're developing this code over 3 months, you may not remember why you named a class X and what the class X is having inside of it. So what are the functions doing inside of this class? So it's better to have a nice name for classes and also for functions. Here, inside this text processor class, we're having three functions. The first function is called count words. So when looking at this function name, we can see that, okay, this function name is count words. So this function probably is going to count the number of words that we are having. Or this function name is reverse text. So this function is probably trying to reverse, for example, a string for us. And also here, the name of the function is to uppercase. So this function probably is going to uppercase the letters or strings or all the whole sentence, etc. So we can guess what this function is doing because this function now is short. But we may have in the future, when we are developing our code, we may have, for example, a function with 200 lines. So it's not easy every time that we want to see what this function does. We need to go through all the lines to understand, okay, this function was doing this. So it's nice to smartly choose the name of the functions. Also, you can put comments. For example, I can type down this function is counting the number of words in a sentence, for example. Okay. And this function is doing, for example, the reversing of a sentence, etc. So this way you can also remember, okay, this function is going to do this for us. So now this function is having one argument. The argument is a string here, we see. And then we are in this function, basically we are counting the number of words in a sentence. To do that, we are using the split function, and then we are calculating the number of words there. So this sentence is splitted into two parts using the split function. So a split function can understand that there are two words here because it detects the number of spaces in between. Then when it counts that, when it splits these sentence into two words, then we are going to calculate the number of words using the len function. Then we are going to return the output here. So in order to call the count word class, we are writing down the name of the class dot the name of the function, and in parentheses I just have one argument that is called hello world, for example. So this is my string when calling this function. Then this function is called, this hello world, let's say phrase, or let's say sentence, it's a small sentence, is splitted into two parts because there are two words here. And then we are, by len function, we are measuring the number of words and we are returning the output. And when the output is returned, we are basically having the output here. And because we are using the print function, we are going to print the output. So number 2 is printed out in the output. Then we are having the reverse text function. So this function basically is going to reverse a string. For example, we call this reverse text function with one argument called Python. And when we call this function, this text is passed as argument, and this text is being reversed using this formula. So colon -1, when we are having it, we are going to, Python is understanding, the compiler understands that we would like to the text to be reversed. So this is how we can reverse a text in Python, for example. Then the reversed version of the text is returned, and we are having the return here, and then we are printing the returned output of the function here, which is this. Okay, so this Python is reversed. So you see NOHTYP. So we are reversing it from the end. So NOHTY and P. And finally, we are having another function called to uppercase. And basically, this function is going to uppercase all the letters in our string. So we call the to uppercase function, and we are having a string, and all of the string is in lowercase letters. So we're having hello, and we are going to use the upper function to make this string uppercase. So this hello is passed as argument. So the text, which is our string now, is written here dot upper function with empty parentheses, and it is going to uppercase all the letters in our string, and we are returning the output of this function. So the hello is now becoming like hello here, and we are returning it here, and the returned output is now inside these parentheses. And because we are using the print function, it is going to print hello for us in the output. So when I run this code, we see that the first result is number 2. So the number of words in this sentence is 2. This is why it is returning 2. So we learned how to calculate the number of words in a sentence as well using a function inside a class. Then also we reviewed how to reverse a string. Here we are reversing it, and also how to uppercase a string now that is shown here. So in this coding exercise, we had a class called text processor, and inside that class, we were having relevant functions that each of them were doing certain tasks related to text operations. The first one, for example, is counting the number of words in a sentence. The second one is reversing a string. And the third one is going to uppercase a string that we are passing as argument when we call this function. So it was a good example to not only review the class concept, but also to review some of the, for example, string functions like the split, len, and how to reverse a string, for example, on how to uppercase. Thank you for watching. Hi, welcome back. In today's video, we would like to talk about two important topics in classes. The first one is constructors, and the second one is destructors. So what is a constructor? A constructor automatically initializes object attributes when an object is created. So it reduces manual work by ensuring every object starts with a predefined state. And it helps in organizing code by keeping object creation structured. Whenever we want to use constructors, we need to use this code, okay? Underscore, underscore, init, underscore, underscore. So this is how we create constructors inside a class. And destructors, whenever we want to create them inside the class, we need to have underscore, underscore, del, and then underscore, underscore. So this is how the destructor is created in a class. Basically, destructors are also used to clean up resources, for example, files or database connections, etc. And it ensures efficient memory management. So in order to create an example for you here, we have brought this example for you. We're going to give you a specific example in which you can learn about constructors like here and destructors like here, okay? So in this example, we are having a class called person. We are creating the class using the class keyword, and the name of the class is afterwards. So person is the name of the class. Then we are having column. Here is my constructor. Here is a function called introduce, and here is my destructors. Okay. And then here in the main part, we are creating an object of the person class. So in order to create an object, we are going to name it something, for example, person1, this is the name of my object here, equals, then we type down the name of the class, which is person, then we are passing two arguments. Why am I passing two arguments here? The reason is because of the constructor. So constructor has a self argument that is always there. So the other arguments are the arguments that we need to use when we are creating an object. So when we are creating an object from the person class and we are having a constructor, now we are having two arguments that we need to declare them when we are creating an object. This self is always there and we need to consider having it. Apart from that, we are having two arguments, name and age. So why I'm passing two arguments here? Because my constructor requires two arguments. So I'm creating an object called person1, and in order to create an object in Python for the person class, for example, I type down the name of my object, for example, person1 equals person, which is the name of the class, and in parentheses, we type down the arguments. So in this case, we need two arguments. There are cases when we need to have one argument or five arguments. It depends on our constructor. So when an object is created, automatically the constructor is called. So this is one of the features. So automatically the constructor is called, and then using this argument, we are initializing these two attributes. So these two attributes are two variables of the person class, okay? And we use this first argument, which we call self, to fill these two variables. So these two variables are name and age. In order to assign some value to them, we use self.name and self.age, and these arguments that are passed when we are creating an object and the constructor is automatically called, these two values are going to be assigned to the self.name and self.age. So let me review it one more time. I am creating an object called person1. In order to create that, we need to equal it to the name of the class person, and in parentheses, we are going to have two arguments. Why two arguments? Because I have a constructor, and apart from self, I'm having two other arguments. So for these two arguments, we're going to have two arguments here when creating an object. So when the object is created, automatically the constructor is called. And these two arguments that are passed for this constructor, automatically name and age, are assigned to name and age. Okay, and they are public variable. In later videos in this section, we are going to talk about other variables as well. So we are having public variables, protected variables, and private variables. We're going to talk about them. So just know that there are three types of variables, and in this video, we're talking about public variables, and we're going to comprehensively review all of them and compare their features. So this name Alice is assigned to self.name, and number 30, which is the age here, is assigned to self.age. So here the constructor is called with the creation of an object, and we are now initializing our attributes that are name and age with the object that is created with these two arguments, Alice and 30. So now we are having an object called person1, and person1 information is stored. Alice is the name and 30 is the age. Okay. After that, we can use that object to call the functions that are inside this class. So I type down the name of the object and then dot and then the name of the function. And when we are calling the function here, I call the function introduce. So this is the name of the function. And as you see, we pass no arguments here when calling the function, because there, apart from self, there is no other arguments here in the function. And we said that by default the self is there. So self is there and no other arguments apart from self is there. Therefore, we call the function with no other argument. So the introduce function is called. When this function is called, basically it is going to print the information of that we stored in the person1 object. Okay, so it is going to show this message. Hi, I am, then put the name of the person, which is Alice, because we assigned these two, let's say, arguments for the first object using the self name and then self age. So I am, then Alice is shown because self.name is used, and I am also the age of the Alice is shown 30 years old here. So because I'm calling the function introduce using the first object, it is going to print the information regarding the first person, because the first person information is assigned as arguments for the first object. So if I have, for example, person2 equals person, and then here I type down Reza, and then the age is 33. So here, if I am creating a new object, okay, now I'm creating a second object with the new information. So the name is Reza and the age is 33, for example. Then I use this object, this new created object, and call the introduce function. Now, if I run this code is going to, let me comment this part. First, call the introduce function using the first object, which holds the information of Alice. Then when I use the second object to call the introduce function, this function is going to print the information that are stored for Reza. So let me run the code. So when I run the code, first of all, we say constructor called, creating an object. So we mentioned that when we are creating an object, automatically a constructor is called. When this constructor is called, this message is shown. Then these two arguments that we passed to this constructor are assigned to the attributes name and age. Okay, so constructor called creating an object. So constructor called creating an object. Then we call the introduce function. So introduce function says, hi, I am Alice and I am 30 years old. So this is the introduce function is printing the information of Alice because we are using the first object to call the function. Then I'm creating the second object. It says again, constructor called, creating an object. So this message is again shown. And then the arguments that are passed to this constructor, which are Reza and 33, are assigned to the attributes self.name and self.age. And then the introduce function is called. When the introduce function is called, the information of Reza is being printed out here because we are using self.name and self.age here. And we are using the second object, therefore it is going to talk about the Reza information because the second object was for Reza. So you see, hi, I am Reza and I am 33 years old. So this is how actually we can have one function, but we can have one class and one function, but we are having different objects and each object holds information of a specific person. After doing all of these things, we are going to delete our let me now add this one, our objects. Okay, and when we are going to delete our objects, the destructor will be called again automatically, and we need to delete them for efficient memory management. So when I delete person1 and person2, this constructor that the name is underscore underscore del underscore underscore is called, and this message is shown. So destructor called deleting object of first Alice and then Reza, because this destructor is going to be called two times because we are having two objects that are being deleted. So one time for person1, which is Alice, and one time for person2, which is Reza. So when I run the code one more time, it says constructor called, then the information of Alice, constructor called, the information of Reza, and then it says destructor called deleting object of Alice and deleting object of Reza. So these two objects are being deleted. Therefore, we make sure that the efficient memory management is performed in our code. So to summarize, a constructor called automatically when an object is created, and it is used to initialize our attributes, and it uses self to define object specific attributes. So this is a summary of the constructor, and for destructors, they are called automatically when an object is deleted, and they can be used for cleanup tasks, for example, for closing files, releasing resources, etc. So in this video, we learned first of all how to create an object of a class, then how the constructor would work, and also how the destructor would work and why they are necessary to be used. And also we learned that if we are calling this function with two different objects, it can show two different information for us. For example, we called the introduce function with the first object, and it was going to show the Alice information. Then we call the function the second time with the second object, which was holding the information of Reza. Then this introduce function was printing out the information of Reza. So this is a summary of how we can use constructors and destructors to increase the efficiency of the memory management, and also help us to automatically initialize our attributes. Thank you for watching. Hi, welcome back. In today's video, we're going to work further with constructors and destructors. Here, I am having a class called person, and I'm having a function called createPerson. I'm having a function called introduce. Then I'm having the constructor and then destructor. And here in the main part, basically, I'm calling only the createPerson function. Okay. So here I would like to create an object inside a function. In the previous video, we learned how we can create an object here. For example, I was typing down, for example, person2 equals, then the name of the class, and then we could, for example, put some information like Alice, 30, etc., and call the introduce function afterwards. This is what we did in the previous video. But here, I would like to create an object inside a function of the class. So in order to do that, first of all, I call the createPerson function. In order to call that, I first type down the name of the class, then I use dot, then I call the createPerson function. In this function, what happens is the following. So this is the name of the function. And here I'm typing down the name of the class again. I'm having two arguments, and it is equal to p. So p is an object that we are creating for the person class, and these are two arguments. And we learned when we are having a constructor, when we create an object of that class, we are automatically calling the constructor. So here we are creating an object inside a function of the class rather than outside of it. Okay, outside of the class. Here, the object is being created, therefore, the constructor is automatically called, and these two arguments, Bob and 25, are assigned to the attributes, which are self.name and self.age. They are assigned. Then everything is finished. We go up here, and we are not showing any message in the output to say, okay, the constructor is called, but we could also show this message saying that the constructor is called. Okay, we could have that as well. So when we create the object, this message is shown because the constructor is called, and these two arguments are initialized and are assigned to initialize the attributes self.name and self.age. Then we go up and continue the execution of this function createPerson, and we use the object to call the introduce function from the person class. So I type down the name of my object, dot, and then the name of the function which is introduced. So this function is now called, and this function is going to print information regarding the Bob, because we are calling this function with an object that was used to, pass arguments and data and information of Bob. So this introduce function is going to print, hi, I am Bob and I am 25 years old. So this message is being shown in the output when the introduce function is called. And then everything else is finished, and we are going to have, for example, here, if we want to delete the object that we are having here, we can delete that. And in order to do that, we can simply just type down the keyword del and then type down the object name. So when we are deleting the object here, we are going to automatically call the destructor, and then when the destructor is called, this message also is being shown out. Object Bob has been deleted. So let me run the code. So when I run the code, first of all, it says constructor is called. How? So let me go through it one more time. When we run the code, we are calling the create person function from the person class. So this function is going to execute these three parts, these three lines, let's say. First of all, we are going to create an object called P. When the object is called, we're going to automatically call the constructor, and the constructor is showing this message. First of all, the constructor is called. Okay. Then the arguments that are passed for calling the constructor, which are Bob and 25, are assigned to our attributes, self.name and self.age. When the constructor work is finished, we go up here, the compiler goes to next line and calls the introduce function using the object that we just created. Then we are having the introduce function being called, and this message is shown. Hi, I am Bob and I am 25 years old. So this function is called, and this message is shown also in the output. After that, the compiler goes back up again in the create person function, because we didn't finish executing this function. It goes to next line, and the next line is deleting the object that we created. Therefore, it is going to delete the object, and when the object is being deleted, automatically the destructor is called, and it shows this message, basically the destructor saying that object Bob has been deleted. So this is how we can actually have an object being created inside a function that itself is inside a class. In the previous video, we learned how to create an object outside of the class for the class, but in this video, we learned how to create an object inside a function that is inside a class here. And then inside that function, we are going to create an object. So automatically the constructor is called, and then we're calling another function in that class. So we are using the object and then the name of the object and dot and then the name of the function. So the introduce function was called, and finally we removed and we deleted the object that is called P, and automatically the destructor was called also to release the resources and for efficient memory management. Thank you for watching. Hi, welcome back. In today's video, we would like to simulate a bank account and how to manage it. Here I'm having a class called bank account, and in this class I'm having a function called show balance. We are having a constructor and also a destructor. And for the constructor, we are having two arguments apart from the self, and one of them is owner, and the other one is balance. Whenever this constructor is called, we're going to show this message. Account created for, then the name of the owner. Basically, whenever this constructor is called, it is going to initialize two attributes for us, owner and balance, using the arguments that are passed when we are creating the object. And here is the show balance function. Whenever this function is called, it is going to show this message. It is going to type down the name of the person, then the balance is shown. And finally, whenever we are deleting and removing the object, the destructor is automatically called and this message is shown. Account for example, Reza is now closed. So in order to work with this system, we need to create an object. So we are creating an object called ACC from the bank account class. To do that, I have the name of my object, which is ACC equals, then the name of the class, which is bank account, and in parentheses, I'm having two arguments. Why two arguments? Because apart from self, there are two arguments in my constructor. So Alice is for the owner and 5,000 is for the balance. And then when the object is created, we learned that the constructor is going to be called automatically, and it is going to initialize our attributes with the arguments that are passed when we are creating the object. So Alice and 5,000 are assigned to our attributes when the constructor is automatically called during the creation of the object. Then after this has finished, this work for the constructor has finished, we are calling the show balance function. When we are calling this show balance, here we are showing this message, the name and then the balance. So we are using the ACC object to call show balance function. Therefore, this part is going to use the attributes that were stored for this Alice, because we use the same object to initialize our attributes through constructor. Okay, so this is why when we call the show balance function with the same object, it is going to show the information for Alice. So it is printing Alice's balance is 5,000. And then finally, we are deleting our object ACC. And when we are deleting that, the constructor also is called automatically and it shows this message. Account for Alice is now closed. We could have another function, for example, for the withdraw, and we could discuss, for example, if Alice is going to withdraw some amount of money, for example, that could be reduced or added if they want to deposit some money to their balance. This could be also possible and one option to extend this exercise. You can do it yourself. For further exercise, you create a new option and a new function, for example, for depositing the money, and another new function for withdrawing money from the bank. And then you could call those functions to add some amount of money or some withdraw some amount of money. But you need to be careful when you're creating an object. You need to have more arguments for the amount of deposit or the withdraw that the person, for example Alice, would like to have. So let me run the code. When I run the code, it says account created for Alice. So we are creating the object, therefore the constructor is called and this message is shown, account created for Alice. Then we are calling the function called show balance, and then show balance function is called and the information of Alice is being printed. Alice's balance is 5,000. And finally, when we are deleting the object, we are showing this message, account for Alice is now closed. So this is how we can use a class, an object, to work with different systems. In this case, we were simulating a bank account system, and it's very useful. We can have it with many other systems as well. So you see that they are practical and they are used in real world. Thank you for watching. Hi, welcome back. In today's video, we're going to work with a shopping cart class, and it is going to simulate a situation where we would like to add some products or item to our shopping list. Here, I'm having a class called shopping cart. We are having a constructor, and whenever the constructor is called, we are showing this message, shopping cart created, and we are simply having a list of items, and it's empty for the moment. Then we are having a destructor also. Whenever the destructor is called, we are having the shopping cart discarded. In between, we are having two functions. So one function is called add items. Whenever this function is called, we need to have one argument, and basically this argument is going to be added to the list that we initialized when we created, let's say, when the constructor was called and was executed. So whenever the add item function is called, we need to have one argument, and that argument, which is our item, is being appended to the item list using the self.items. Okay. And then we are saying that that item is added to the cart. So this is how the add item function works. And then we are having a function called show cart. And whenever the show cart function is called, it is going to show the items that we add in this list. Okay, so cart contains, and it is going to simply give us the items that are in this list for us. So here in the main part, I'm creating an object called cart. And then in order to create an object of shopping cart class, I type down the name of the object equals the name of the class. And you see that inside parentheses, we have no argument. This simply means that the constructor requires no argument. And when we check the constructor, we see that we have no other argument apart from self. So when creating an object, we don't need to have any arguments. And when we are creating the object, automatically the constructor is called, this message is shown, and then the list is created. After that, we would like to add, for example, items to our shopping list. We would like to call the add item function. In order to do that, I use the object, then dot, then the name of the function, which is add item. And in parentheses, we need to have one argument because this function, apart from self, has one argument. So laptop is added to my shopping list now, okay? Because I'm calling the add item function with the laptop. So laptop is my item, and this item is being appended to my list, which is accessible using self.items. So the item, which is laptop in this case, is appended to my shopping list. Okay. And this message afterwards is showing that, for example, laptop added to the cart. After that, I call the add item again function. I call this function one more time, and I now add phone. So my shopping list is now updated. Now the item is phone, so phone is appended to my items list. Now it shows this message, phone added to cart. Then after that, we are going to call the show cart function. So we would like to know, okay, what is the shopping list now? What is the status? How many items are there, etc. We would like to know how many items we added to this shopping list. It's like the shopping basket, let's say. And then when the show cart function is called, we need no argument because apart from self, we have no other arguments. And it is going to say cart contains, and it is going to show me the list that we are having. And finally, we are going to remove the object that we created. Therefore, the destructor is going to called, and then this message is shown, shopping cart discarded. So let me run the code. So when I run the code, it says shopping cart created. This is this message. So when we are creating the object, when we are creating the object here, the constructor is automatically called, And therefore, this message, the constructor is automatically called, this part. Then this message is shown, shopping cart created, and this list is created as well. So shopping cart created. Then we are calling the add item function twice for laptop and phone. It says laptop added to the cart and phone added to cart. So here, first of all, laptop is appended to my list, and then it says laptop added to cart. Then the phone is appended to my list one more time. It says phone added to the cart. So here are they. Here they are. And then we are calling the show cart function. Here, when we call the show cart function, it says cart contains, and it is going to print the elements of the shopping list, let's say, and it says cart contains laptop and phone. So these were the items that we added. And finally, we are deleting the object. And when we are deleting the object, the destructor is called automatically, and it is going to show this message: shopping cart discarded. So this is how we can have a shopping cart class that has a constructor for initializing our shopping list, for example. And then this was the constructor, sorry. So the constructor that does the initialization of my list, then a destructor that we are having to remove the object, and it is going to help me to use the memory efficiently, and then two functions to add items and show me the items that I already added to my basket or to my shopping list. This is how it works, and it's very useful, and you see that the practical examples are very useful to understand that what you're learning is actually applied in real world scenarios. Thank you for watching. Hi, welcome back. In today's video, we would like to simulate a managing system for student record system. Okay. In order to do that, we do everything through a class in Python. So here is my class called student. In order to create a class, we know that we need to use the keyword class and then the name of the class. And in this case, the name of my class is student. Then we have the column. Here I'm having the constructor and then the destructor and then a function to show the details. So the constructor has two arguments apart from the self. One of them is called name and the other one is student ID. Whenever the object is created, the constructor automatically is called and this message is printed in the output. The name of the student is shown and then saying that with this student ID that the student is enrolled. After that, two parameters that are passed as arguments are assigned to self.name and self.student_ID. This is my constructor. And I have a function called show details. So whenever this function is called, we need no argument because we only have the self in the parentheses. So no argument apart from self is included. And whenever this function is called, it is going to basically print the student name and the student ID. And finally, we have a destructor. And the destructor is going to be called automatically when we are removing or deleting the object that was created initially. So whenever that object is being deleted, the destructor is going to be called automatically, and this message is shown in the terminal or in the output saying that student record deleted, student, and then the name of the student and the record deleted. Okay, now I would like to create an object of this class called student. And this is how we can create an object. The object name in my case here in this example is student1. And we know that when we want to create an object, we need to type down the name of the object. For example, I type down student1 equals then the student, the name of the class, and in parentheses, we need two arguments. Why? Because the constructor requires two arguments apart from self. So the first argument is the name of the student, which is John. and then the student ID is 101. So when this object is created, the constructor is automatically called and it is showing this message, student John, and then the ID is printed 101 enrolled. Okay. Then these two are passed arguments are assigned to self.name and self.student underscore ID. So we created an object and we passed two arguments that are the information of our first student, let's say. After that, we use the same object and call the show details function. And in parentheses, we have no argument because we need no argument. And when this function is called, this function is going to print this message, student John, and then the ID is printed here, okay, in the output. And finally, we are deleting the student object. So the object is removed, and now when it is removed, the destructor is called and saying that student John record deleted. Let me run the code. So when I run the code, it says student John ID 101 enrolled. This is the message exactly coming from the constructor because we're creating an object. So this constructor is activated and this message is shown. Then this message is shown in the output, student John ID 101. So this is a message from the show details function. And this is where actually we call this function. And finally, we are having student John record deleted here. And this comes from this part, which is the destructor, and the destructor is activated actually when we are deleting the object that we created. So if we want to add a new student, we can create a new object, for example, student 2. Then we can type down the information of the second student, for example, Alice, and the student ID is 102. Then we call the show detail function, and actually after that we are going to remove the object for the efficient memory management. So when I run the code one more time, we see all these informations. For example, student John enrolled, student John, this is the show details function message. Then we are having the second object being created. So we are saying that, okay, Alice enrolled with the student ID of 102. Then we are showing the details of the second student, Alice ID 102, and this comes from this call of show details function. And in the end, the records of both students are being deleted because we are removing both objects in the end of our program. So when I create the second object and I use that object to store, or let's say pass the information of the second student, whenever I call the show details function with the same object, it is going to show the Alice information for me. But if I call the show details function using the first object, it is going to show me the John details. And this is how we can create several objects from one class and store information of different students, for example, here in managing a student record system. Thank you for watching. Hello, welcome back. In today's video, we would like to simulate a system that manages a library book checkout. And we are going to do that through a class. This is the keyword of the class because we would like to create a class. And the class name is library book. We are having our constructor, and the constructor has two arguments apart from self. And the arguments name are title and author. So we are having two arguments apart from the self in our constructor. And whenever we are creating an object of the library book class, we are going to automatically, let's say automatically this constructor is called. And then this message is shown. Book, then the title by author is now available. And then we are assigning these two arguments that are passed for constructor, or we are assigning them to self.title and self.author. And then we are having a function called checkout, and it has one argument apart from self, and the argument name is user. Whenever this function checkout is called, this message is shown saying that, for example, user, the name of the user, for example, checkout, and then the title of the book. And we are having a destructor, and whenever we are deleting the object that we created from this class, the destructor automatically is called, and this message is shown in the output. We are saying that, for example, book, and then we put down the title of the book, removed from library system. So let me illustrate all this information through an example. Here I would like to create an object from the library book class. So I type down the name of my object. I would like it to be book 1. You could have like X, you could have H, you could have R. It depends on you. It's just a name. It's not important. So I name it book 1 equals then the name of my class, which is library book, and in parentheses I write down the title and the author of a book. For example, 1984, it's a famous book by George Orwell. Therefore, I am creating an object and storing this information. Okay, the book title is 1984 and the author is George Orwell. Then I would like to call the checkout function. In order to do that, I use the same object that I created for this book, and I put a dot, and then the name of the function is written here. And then in parentheses, I have the name of the user who actually took this book. For example, Alice took the book called 1984 by George Orwell. Okay, so this function is called. Whenever this function is called and this message is shown saying that, okay, Alice checked out 1984. And finally, we are here deleting the book 1 object that we created from this class. And when we are deleting this object, the destructor is automatically called and saying that book 1984 removed from library system. So when I run this code, we see that it says book 1984 by George Orwell is now available. So this is exactly the message comes from the constructor because we created an object. Then we are saying that, okay, Alice, for example, she is one of the members of the library, checked out 1984. So the book called 1984 is checked out by Alice. And finally, when we are removing the object, we are showing this message book 1984 removed from library system. So here this message is shown. We could have another object, for example, for another book, for example, Harry Potter. We could have another object for another book. So different books could be inserted into this system by using different objects, and this is how actually we can manage a library book checkout system in Python. Thank you for watching. Hi, welcome back. In today's video, we would like to create a class called car. Here is my class. I have a constructor here that has 3 arguments apart from the self, and these 3 arguments are assigned to attributes called self.brand, self.model, and self.year. So whenever we create an object of the car class, we are going to call automatically the constructor, and these arguments are assigned to attributes. Then we are having a function called display info. So whenever this function is called, we're going to print this information. So the year, the brand, and the model. So the attributes. Okay. Now let us create objects.
The first object is created and it is called car1. In order to create that, it is assigned to be equal to car, the name of the class, and then in parentheses we are having 3 arguments as we discussed here. So the first one is the brand, the second one is the model, and the third one is the year. For example, the first object is storing information regarding a Toyota Camry and for the year of 2022. Then we would like to create another object called car2, and this one holds the information regarding a Honda Civic for 2023. So these 2 objects are created, and these 3 arguments for each object is passed as argument when calling automatically the constructor. So the Toyota, which is the second argument here and the first argument here, let's say the first argument without considering the self. So brand is the first argument, which is Toyota in the first object. Then this brand is assigned to the self.brand attribute. The model Camry is assigned to self.model, and 2022 is assigned to self.year. So this is how the information is stored for the first object. And for the second object, Honda, is assigned to the attribute self.brand. Then Civic is assigned to self.model, and 2023 is assigned to self.year. So this is how these 2 objects are created, and they are passing information regarding 2 different cars. Then in order to call this display information with the first data, the data for the first car, let's say, so we would like to show information regarding the Toyota, we need to use the first object because we use the first object to pass these arguments. This is why when we want to talk about Toyota now, we're going to use the same object. So car1.displayInfo, so this function. Then whenever this display info function is called, this line is being printed in the output saying that, for example, 2022 Toyota Camry. And then we use the second object to call the same function. However, this time the information regarding the second car is going to be shown in the output saying that 2023 Honda Civic. So when I run this code, we see the output is like this. So one time the first function is called, the display info function is called for the first object. Then the same function is called for the second object, and these 2 information are shown in the output. Please note that for the constructor, we didn't have any message to be shown in the output. So we could have, for example, a message saying that, for example, the constructor is called. Okay, so now when we run the code again, when we are creating these 2 objects, we see that the message is printed twice in the output. And also we don't have destructor for this example, but we could have also a destructor by which which could be activated when we are deleting these 2 objects. For example, in the end, we could have car1 and then car2. So now we are deleting these 2 objects, but nothing is being printed out in the output because we don't have a destructor in our code. If we were having a destructor, we could have a message like a print showing that, okay, the destructor is activated or it is called. Thank you for watching. Hi, welcome back. In today's video, we would like to discuss class attribute and instance attribute. Here we are having a class called dog. We are having a class attribute called species, and it is assigned to be canine string. So this is a class attribute because it's not inside any function or any constructor or destructor. This is for the class individually. Then we are having a constructor which has one argument. Then whenever we are creating an object, that name is assigned to the instance attribute. Okay, this instance attribute is in the constructor. However, we are having a class attribute as well. So now I'm creating an object called d1 for the dog class, and when we are passing the argument, the name is body. Okay, then I create another object of the dog class and I call it Charlie. Okay, we need to have one argument because our constructor requires one argument apart from the self. So when I create this object, this constructor is automatically called and the body is assigned to the instance attribute, which is self.name. Then when I create the second object, the Charlie is assigned to the instance attribute, which is for the second object. Okay. Now I would like to access this class attribute. In order to access the class attribute, we can use objects of that class. So here I use the first and the second object to access this species class attribute. So simply I type down the name of my object dot the name of the class attribute, which is species. And I do the same for the second object, and I use the print function to print it in the output. So when I run the code, I see cannon is being printed in the terminal 2 times, one using the first object, one using the second object. So we learned that in order to access a class attribute, we can use any object of that class. It doesn't matter if the first object or if it is a second object. When we have an object of that class, it is possible for us to access that class attribute through that object. Okay, then how about the names that we stored in the instance attribute here? How can I access them? Because I initialized body to my instance attribute and I initialized Charlie as well to the instance attribute. How can I access them? Now that I don't have a function like a display function to display information whenever I call that function using the object that I created here. In order to access those instance attributes, it's very simple. We type down the name of the object dot then the name. So name is the argument that is considered for the constructor. Okay, and then I use the second object again, and I have again the name after a dot. So when I run the code, we see that using the first object, body is printed in the output, which is here that we initialized it. Then Charlie is shown in the output using the second object, which is what actually we had initialized while creating that object. So in this video, we tried to distinguish the class attribute and instance attribute. So when we would like to have access to the class attribute, we can access it easily through any of the objects that are created from that class. However, when we would like to have access to one specific instance attribute, it is necessary to use the same object as the same instance. Okay, so for example, if I want to have the instance attribute, the first instance attribute, I need to use the first object, not the second object. If I use the second object, I will have access to the second instance attribute. Okay, so this is how we can distinguish class attributes and instance attributes in Python. Thank you for watching. Hi, welcome back. In today's video, we would like to talk about class methods. Here I'm having a class called school. We are having a class attribute called school underscore name. Then it is assigned to a string. So a string is ABC High School. This is my class attribute. Then I'm going to talk about the class method later, but then I'm having a function called change underscore school underscore name. And the first argument is CLS, and then the second argument is the new name. So whenever this function is called, we need to have one argument apart from the CLS. Then that argument is assigned to the class attributes using the CLS. Okay? So let me illustrate it with an example. Here is my example. Now this is my class. Then as we discussed, the class attribute is named school underscore name, and it is assigned a string that is ABC high school. I would like to print this. In order to access that, I write down the name of the class, which is the school, then dot, then the name of the class attribute, which is school underscore name. And I use the print function to print it in the output. So when I run the code, I see that in the output, we see ABC high school. So it is printed in the output. However, what if that I would like to change this class attribute? One way to do that is class method. So if we want to change a class attribute, using the class method, we should have @sign class method, then have a function to do the job for us. And this CLS is our parameter that can help us to access this class attribute and to modify it. For example, here I want to call this change school name function. I use the name of the class, which is a school. We learned it before, how to call a function inside the class. We type down the name of the class dot the name of the function, which is change school name. And then because this function requires one argument apart from the CLS, we are going to pass a new argument. So we would like this string XYZ Academy to be there for our class attributes. So we would like to replace ABC High School with XYZ Academy, this string. Okay, so we would like to modify the class attributes, and we're going to use the change school name function. Therefore, I type down the name of the class dot the name of the function, and then in quotes I type down my new name, let's say, and I assign it to school underscore name using the CLS. Then we are going to print the same class attribute just like we did in the above line. So we use the print function. I type down the name of the class, then dot, and then the name of the class attributes, which is class name. So now this time we see that this class attributes has been modified to XYZ Academy. Initially it was ABC High School, but we used a class method in order to modify it. And this is important to type down the @sign class method, because if I comment this and I run the code, I will have errors. It does not allow me to do this because it's a class attributes and it's not possible to directly modify it. So when I uncomment this part and the class method is there and I run the code, we see that using the class method, we are able to modify this class attributes. Also, this CLS means class itself. In this case, it is talking about school. So we use this CLS in the class method to modify the class attributes. So this is how we can use the class method in order to modify a class attributes. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about encapsulation. What is encapsulation and why do we need to use them? So far, while we were discussing different coding exercises for classes, we were using public attributes, let's say public variables in the class. But there are two other types of attributes in classes in Python. The first one was the public attributes that we already used. There are two others. The second one is protected attributes and private attributes. What are they and why do we need to use them? So we use encapsulation because of data hiding. It prevents direct modification of variables, which protects object integrity. Also, it ensures that the data is not modified accidentally. And we provide getter and setter functions, or let's say methods, to control how data is accessed or modified. For example, in C++, when we would like to talk about attributes, we are going to have public, protected, and private. If you're familiar with C++, you know that we use these keywords in order to talk about different attributes in one class. However, in Python, the story is a bit different. So if we want to have a public attribute, we simply type down the name of the attribute and it is accessible from anywhere. And so far, you saw that we were simply typing down the name of the variables and they were declared to be public attributes in Python. So we could access them from anywhere in the code. However, if we would like to have, for example, a protected attribute, we need to have underscore and then the name of the variable or the name of the attribute. So it is indicated by a single underscore, and it's a convention that suggests the variable should not be accessed directly, but it is still accessible. We're going to go through all these details in the coding exercises in the following videos. Then, if we would like to have private attributes, we are going to have two underscores, let's say double underscore, and we in Python we perform name muggling or that make it difficult to access these private attributes directly outside of the class. And if I want to make a summary table for you regarding these three attributes, we can say modifier is public, protected, and private. The way that the syntax work is we have self dot the name of the variable. Let's say var is the name of the variable. So when we type down simply the name of the variable, it's public. When we have one underscore, it's protected. And when we are having two underscore, or let's say a double underscore, it's a private. So regarding the access from outside of the class, the public one, yes. The protected one, also yes, but it's not recommended. And the private attributes are not accessible outside of the class unless we are using name muggling that we are going to talk about it later. And access for subclasses. So subclasses are the discussion of the inheritance that we are going to learn in the following videos. But for the moment, just know that for public and protected variables or attributes, it is possible to use them in subclasses. However, for private attributes, it's not possible. We're going to review this again when we're talking about subclasses and inheritance in Python. And direct modification, is it recommended for public attributes? Yes. For protected, no. And for private, it's not possible. So this is a summary of how these three attributes work in Python. In the following videos, we're going to dive deeper into concept of these three attributes and provide coding exercises so we can see how practically we can work with these three attributes. Thank you for watching. Hi, welcome back. In this video, we're going to talk about public attributes. Here is my class called car. Here is my constructor, and here is my function. I'm creating an object of this class called car, and we are passing two arguments because our constructor requires two arguments, brand and speed. So Toyota and 180. This is the two arguments that we are passing, and these two arguments or parameters are assigned to our attributes using the constructor automatically. Then we are accessing these public attributes using the object. So car1.brand and car1.speed, using the print function, we can see them in the output, Toyota and 180. And also we can access the function called show underscore details. And this function, whenever it is called, it is going to return this for us. So the brand and the speed of the car, for example. So here I use the print function, and then using the first object car1, then dot, then the name of the function. I'm calling the function, and we are showing this message in the output. So brand Toyota and speed 180. So here in this example, we learned that in a class, when we are having a name just like this and with no underscore, we're talking about public attributes. And we saw that outside of the class, it was easy for us to access these two public attributes. We could simply print them using the object, and we could simply also call the function using the object that is defined inside the class. So this function defined inside of this class, and using the object, we are accessing it. In the following videos, we're going to talk about other attributes that we can use in classes in Python. Thank you. Hi, welcome back. In today's video, we're going to talk about protected members or attributes. So they should ideally be accessed only within the class using methods, or let's say functions, rather than directly. But here we are going to access them directly and also using methods to see how we can access these protected attributes. Here is my class called employee, and it has a constructor, and it needs two arguments. So these two arguments are assigned to my attributes. But the first attribute is a public attribute because it has no underscore. But the second one is a protected attribute as it has one underscore. So my salary attribute is a protected attribute. Then I'm having a function called show salary, and basically this function is going to show me the name of the person and then the salary of that person. And you see that when I'm accessing the public attribute, I don't use the underscore, but for the protected, I use the underscore. Then I'm having a function called update salary. And in this function, we are going to, whenever we are calling it, we need to pass one argument. So the new salary needs to be passed. First of all, we are checking to see if the salary that is entered is larger than 0 or not. Because if it's not larger than 0, probably we made a mistake and we fall into the else part and we print invalid salary. However, if the new salary that we entered is larger than 0, we are going to assign new salary to our protected salary attribute, and then print this message saying that salary updated to, and then the new salary is shown here, and the new salary that is assigned to our attribute. And this is my class, basically a constructor and two functions. This function is the show function, and this function is the update salary. Then I would like to create an instance, or let's say an object of this class. I name it emp1 equals the name of the class employee, and we are passing two arguments, name and salary. And these two arguments are assigned to our attributes. Then we would like to access protected attribute. We can do it directly outside of the class, but it's not recommended, but it is possible at the same time. So I use the object dot the name of my protected attribute, which is underscore salary. So I use the print function to print this value, which is 50,000 because we just initialized it. So this is how when I run the code, we see that 50,000 is printed in the output. So we are directly accessing a protected attribute. It's not recommended, but it is possible to do that. However, a better way to do that is to access via a method or a function. How to do that? So we have a show salary function here for this job, actually. So I use the object, then dot the name of the function show underscore salary. And whenever this function is called, it is simply showing the information of the employee and the salary. And we are using the print function to print it in the output. So we see that employee John Doe salary is 50,000. So this is the better way to access protected attributes rather than just directly accessing them. What if I would like to modify these attributes, like protected attributes? In order to modify them, we had an update underscore salary function. So I write down the name of my object dot the name of function, and I pass one argument. So this new salary is my argument. Salary is now 60,000. So 60,000, is it larger than 0? Yes. Then assign that 60,000 to the protected attribute and show the updated protected attribute. So we see that it says salary updated to 60,000. After doing the update of the salary, we are calling the show salary function one more time to make sure the modification has been done correctly. So we call it, it goes up here and it shows employee and the salary. So here we see that employee John Doe and salary is 60,000. So to summarize, in this video, we talked about protected attributes and we learned how we can directly access them and how we can use methods or let's say functions to access them. So it's possible to access them directly, but it's not recommended. However, it's better to do that using methods or functions. Also, we learned that we can modify protected attributes, and we had a function called update salary here that was doing the job for updating the salary amount for us. Thank you for watching. Hi, welcome to this video. In today's video, we're going to talk about private attributes, or let's say private members. Here we are having a class called bank account. We are having a constructor that has two arguments, account number and balance. And whenever we are creating an object of this class, these two parameters or arguments are being assigned to my attributes. And you see that these are private attributes because they are having two underscores, or let's say a double underscore. Because they are having double underscore, we realize that they are private attributes. We are having a function called deposit, and whenever this function is called, we need one argument called amount, and that amount is added to the balance of our bank account. And we see that when we would like to update this balance attribute, because it's a private attribute, we are having double underscore. And then we are showing this message, deposited, and then the amount is shown, and the new balance is also being printed. Then we are having a function called withdraw, and it also requires one argument. So when we call this function, we pass one amount as argument for calling this function. Then we check if this amount that we would like to withdraw from the bank account is lower than or equal to the current balance of our bank account. If so, it is going to reduce that amount from the balance, okay, and then show this message, withdraw, and then show the amount that we want to withdraw, and then show the remaining balance of our bank account. And if the amount is not lower than or equal to balance, it means that it is larger than the balance. So in this case, we are falling into this else part and we are saying that insufficient funds because we would like to withdraw some amount of money that we don't have that much in our bank account. For example, if we want to withdraw $10,000 and we only have $5,000, it shows the message insufficient funds. And also we are having a function called getBalance that it is going to show the amount of balance that we have in our bank account. Here we are creating an instance, or let's say the object of the bank account class, and we are passing two arguments. What are these two arguments? Account number and balance. So the account number is just a random number that I'm writing down here, like 1 to 9 is the account number, we assume that. And the balance, the current balance of the bank account is $5,000. So this number bank account is assigned to the account number private attribute, and then the 5,000 is assigned to the double underscore balance attribute of my class. Then, if we would like to try to access a private attribute like this, we are going to have errors. So we cannot use the object and then dot and then the name of the private attribute. So when I run, we see that we are going to have errors here. And the error cause is because we are trying to directly access a private attribute here. Okay, so when I comment this part and I run the code one more time, we see that we have no error and everything works perfectly. But when we want to access directly to the private attribute, it returns an error. So this is the first lesson of this coding exercise. We cannot directly access private attributes unless we are using name mangling method. So we are going to talk about name mangling as well in a few minutes. But directly, it's not possible to do that. In order to access private attributes, the correct way is to have a getter function. And we had a getBalance function actually. So we use the name of the object, then dot, then the name of our getBalance function. Basically, this function is going to return the amount of the balance that we have in our bank account. So in the print function, it is used, so it is going to print the amount that we have currently in the balance private attribute. And because we just initialized the object, we know that 5,000 is a number that we have in our current balance because we didn't do any deposit or withdraw. So first of all, it is going to show this 5,000 to us, as we see here when I run the code. Then we are going to deposit some amount of money and also withdraw some amount of money. In order to call the deposit function, we use the object, then the name of the function, then the amount, 2,000. So this 2,000 that is passed to the deposit function is added to the current balance. So the current balance is now 7,000. So it says deposited 2,000 and new balance is 7,000. So this is how it works with the deposit function. This 2,000 is added to balance and this message is shown. And then this message is shown deposited like 2,000, new balance, and then the new balance, which is 7,000, is shown. Then we would like to withdraw some amount of money. So we use the first object to call the withdraw function and we pass 3,000 as the argument. It means that we would like to withdraw 3,000 from the bank, from our balance, from our bank account. So first of all, we check that if the 3,000 is lower than the balance of the bank or not, bank account or not. So we saw that we updated the balance and it is now 7,000. So we check 3,000 is lower than or equal to 7,000. Is it true? Yes. If it's true, reduce that 3,000 from the 7,000 and type down withdrew 3,000 remaining balance 4,000. So it is going to show this message in the output. Okay. And we are seeing that withdrew 3,000 remaining balance 4,000. How it works, it is going to check 3K is lower than 7K. Yes. Then reduce that 3K from 7K. And why the 7K is the balance? Because we just deposited 2K to the balance in the previous step. So if you remember here, we added 2,000. So we already had 5,000. We added 2,000, so it is now 7,000, and 7,000 minus 3,000 that we want to withdraw, it is 4,000 that is shown here in the output. Okay, so the correct way to access a private attribute is to use a function or a method that do that for us, like the get balance. However, we can also access them using name mangling method. To use name mangling method, we type down the name of the object, then 1 underscore, then the name of the class, which is bank account, and then 2 underscores, then the name of the variable, which is the balance. So 2 underscore balance is the name of my private attribute here. Before that is the name of the class, and before that we are having 1 underscore dot, and then before that we are having the object that we created from that class. So in this video, we learned how to work with private members or attributes, and how we can directly access them only through the name mangling method, but it's better to use a getter method, for example, the get balance. So there is a function that returns that balance for us. And we learned how we can update the private attributes in a class using, for example, a deposit function that we are going to add some amount of money to our bank account, or the withdraw function that we are going to withdraw some amount of money from our bank account, and the balance attribute, which is private, is now being updated after each call of one of these two functions. Thank you for watching. Hi, welcome back. In today's video, we are going to use getters and setters for private attributes. Here we are having a class called student, and the constructor requires two arguments, and we are going to assign, actually this constructor is going to assign these two arguments to our two private attributes. So one of them is name and one of them is grade, and they are private because we see double underscore there. Then we are having the getter method function, which is called getGrade, and basically it is going to return the grade for us. So whenever this function is called, it is going to return the grade. So this is why we are naming it a getter method. So it is going to get the method, get the grade, sorry, and show it to us. Okay, so it is going to return the grade for us. So it is a useful way to access private attributes. Then we are having the setter method called setGrade, and it requires one argument, and the argument is the grade that we would like to have for a student, for example. And when we are calling this setGrade function, we would like a value to be assigned or to be set for our private attribute. We are going to do it using setter methods, using this set underscore grade function. So when we call this function, we need to have one argument, and first of all we check if that argument, if that number, if that value, let's say, that we pass while calling this function is something between 0 and 100, because this is the range in which we can provide a grade. If this condition is true, assign the passed argument to our grade attribute. Otherwise, show this message: invalid grade. It must be between 0 and 100. For example, if we call this function with number 150 or 120 or -20, it is going to show this message invalid grade. So let me illustrate this concept with an example. Here we are creating an object or an instance of this class called student1. Then the name of the class is written, which is the student. Then we are having two arguments, Alice and 85. So the name and the grade. So when we are creating the object, we learned that the constructor is going to be called automatically and these two arguments, Alice and 85, that are assigned are these two arguments that are passed while creating the object are assigned to our private attributes that are on double underscore name, double underscore grade. Okay, so here we created an object. We are passing two arguments, Alice and 85, and these are assigned to our private attributes. Then we would like to access the private attribute that we have through getter method. To do that, we simply use the print function. Then we, in the parentheses, we write down the name of our object, which is student1, dot, and then the name of the function, which is getGrade, and we have nothing in parentheses because we, apart from self, we have no argument in parentheses for the getGrade function. Therefore, the way that we can call this function is just writing down the object that we created from the student class dot the name of the function. And this is going to actually return the grade for us. So whenever this function is called, it is going to show the grade, which is a private attribute. So it is a correct way to access a private attribute. Okay. And therefore, we are going to print the output, the returned value of this function, which is 85, because the grade is going to be shown. It is 85, and it is going to be printed in the output. So we expect to see number 85, first of all, when we run this code. Then we would like to modify this grade. But how do we do that? In order to modify the grade, we use the object dot, then the name of the set underscore grade function, because this function is going to modify the private attribute for us. And we are having the number 90 being passed as the argument. So the set grade function is called and 90 is passed, and we are checking to see if 90 is between 0 and 100. Yes. Therefore, assign 90 to our private attribute, which was 85 before. So the double underscore grade now equals 90. Okay. So now we modified the grade, and we would like to again call the getGrade function to show us the grade that we modified, and we expect to see 90 when we call the getGrade function using the student1 object. After all, I would like to modify one more time the grade attribute, but this time I use the object and I call the set grade, and then I type down number 150. So this set grade function is called. When this function is called, 150 is passed as argument. Here we check is if 150 is between 0 and 100. No, it's not true. Therefore, it is going to show this message. Invalid grade must be between 0 and 100. So when I run this code, first of all, we see number 85 being printed in the output coming from here. Using the getGrade function, we were accessing the grade attribute, which was a private attribute. Then we modify the grade using the setGrade function. After that, we are calling the getGrade function again to show us the modified grade attribute. So we see that it's 90 now. Finally, we would like to set the grade. So we would like to modify the grade one more time, but we are sending one number that is more than 100. So the number should be something between 0 and 100, but we are passing the argument 150. Therefore, when we are talking about 150, it's not passing this condition, so it is not going to be assigned to our grade private attribute. Finally, it is going to show this message because we fall into the else part, and here it says invalid grade must be between 0 and 100. So in this video, actually, we learned how to use setter and getter methods to access or modify private attributes in Python. Here we were having a getter function simply returning the value of the private attribute, and we were having a setter function that was assigning a new value to our grade private attribute. And if the new grade was not something between 0 and 100, it was going to show this message to us in the output saying that invalid grade must be between 0 and 100. Thank you for watching. Hi, welcome back. In today's video, we are going to do some further coding exercises for encapsulation in Python. Here we are having a class called car. Then we are having a constructor that requires two arguments, brand and max speed. The brand is a public attribute. The max speed, however, is a private attribute. Then we are also having another private attribute that we are initializing to be 0, which is current speed. This is my constructor. Then we are having a function called accelerate, and it requires one argument called increase. Then we check if the current speed, which is the private attribute, plus the increase amount that we would like to accelerate the speed is lower than or equal the max speed of the vehicle, then we are going to assign that increase to the current speed. For example, if the current speed is 50, we would like to increase it by, like, for example, 20 kilometers per hour. And the max speed is 100 kilometers per hour, okay? So we are going to check if 50 plus 20 is lower than or equal to 100. Here is the formula. The current speed, which is 50, for example, plus the increase amount is 20, is lower than 100 if we assume the max speed is 100. If so, add the increase amount to the current speed. If so, current speed will become 50 plus 20. So it will become 70. Okay, we are updating the current speed. And we are showing this message in the output saying that accelerating current speed, for example, 70 kilometer per hour. And if the current speed plus increase here, for example, is not lower than 100. For example, the current speed is 50 and we would like to increase it by 80. And the max speed is 100. So this formula is not correct. If this condition is not correct, we are going to fall into this else part and we are showing this message, cannot exceed max speed of, and then max speed is shown. This is the accelerate function. We are going to check, basically, to summarize, in the accelerate function to check the current speed that and the amount that we would like to increase the speed. If the addition of these two numbers is lower than the maximum speed of the vehicle, it's okay. We are going to increase the speed, and we are going to increase the value of current speed. However, if this condition is not true, we are going to say cannot exceed the max speed of, for example, 100. This is basically what the accelerate function is going to do. Then we are having another function called break. This function requires one argument, which is called decrease. And we are saying that, okay, if the current speed minus decrease is still larger than or equal to 0, and reduce that amount from the current speed. For example, if the current speed is 50 and we would like to decrease it by 20, let's say 30, and it is still larger than or equal to 0, which is true because 70 minus 30 will be 40, and 40 is actually larger than or equal to 0. Therefore, we are going to decrease that amount from the current speed. It means that we are going to have the current speed equal to 40. Okay, it was 70 and we reduced 30 amount, so it is now 40. And we are going to show this message breaking current speed, and we are going to show the updated current speed. However, if the current speed minus decrease is not larger than or equal to 0, for example, the current speed is 70 and we would like to decrease the speed by 100, and it is not larger than or equal to 0 because it will be minus 30. If this is the case, this condition is not true. Therefore, this part is true, and we are going to assign the current speed to 0 and saying that car stopped. Okay, because we cannot have a current speed of minus 30. We are going to assign it to be 0 now, and we show that car stopped. Why? Because the decrease amount was larger than the current speed. And finally, in order to know the current speed, because it's a private attribute, we see here it's a private attribute, we have a getter function called getSpeed. Basically, this function is going to return the current speed for us. So whenever this function is called, it is going to show the current speed for us in the output. Now, I would like to create an object or an instance from this class. It is called car1. It is created from car class, and we are passing 2 arguments when creating the object because we are having a constructor and we need brand and max speed. So the brand is Tesla and the max speed is 200. Okay, so brand is assigned to the self.brand, then max speed is assigned to this private attribute, and current speed is 0. So the constructor worked and assigned the assignments. Then we are calling the car1. We are calling, the accelerate function using the car1 object. Or we are saying that car1.accelerate 50. Okay. So when we call this function with number 50, we say current speed is 0 plus 50. The result will be 50. Is it lower than or equal to max speed, which is 200? Yes. So add that 50 to the current speed and show this message. Accelerating current speed is 50. This is what it is going to be shown in the output. Then we are going to show this message. We are going to call the accelerate function one more time. And we are saying that, okay, now I call the accelerate function with number 160. Okay. And when this number is called, what is shown in the output is the following. We come here, the accelerate function is called again. This 160 is the argument that is passed. So 160 plus the current speed, which we calculated from the previous call, which was 50. Now we are adding another 160. It will become 210. Is it lower than the max speed, which is 200? No, it's not. It's not lower than 200 because, let me remove these, because we calculated the current speed from the previous call, it was 50. Now we are adding 160, okay? And we are checking to see if it's lower than 200. It's not, it's 201. Therefore, this condition is not true, okay? And this else part is going to be executed saying that cannot exceed max speed, which is 200, okay? So here we should have this message again shown here, okay? Then what happens if we want to accelerate the car by 10 unit? So we call the accelerate function, the current speed is 50. We are accelerating with 10. So 60 is lower than 200. Yes, it's lower than 200. Then we are going to add that 10 to the current speed, which is 50. So the current speed will be 60 as we expect here. So it is going to be 60. Then we are going to call the break function with number 30. So our current speed is 60. We are going to call the break function. This is the break function, and we would like to decrease the speed by 30 units. We are checking current speed minus decrease, which is 60 minus 30. Is it larger than 0? Yes, it's 30. So 30 is larger than 0. So it was something like current speed is 60 minus 30. Is it larger than 0? Yes. Yes. So it is going to mention that current speed equals 60 minus 30. So current speed equals 30 now. We decreased it. And we are going to show this message breaking current speed 30. And finally, we're going to call the break function one more time, and we would like to decrease the amount by 200. So 200 is passed here. We are checking to see, okay, current speed is 30 minus 200. Is it larger than 0? No, because we are currently 30 kilometers per hour. We are going to reduce by 200. Is it larger than 0? No, it will be minus 170. Because this condition is not true, it is going to fall in the else part, and it is going to say that, okay, current speed equals 0, and show this message, car stopped. And now the car has stopped. And finally, when we call this, when we run this code, we exactly see what we expected. So first of all, we are creating the object, and we are having two arguments, Tesla, and the maximum speed is 200. We are having the accelerating current speed 50 because we added 50. Then we would like to add another 160. It says, no, it's not possible. The max speed is 200. So 160 plus 50 is larger than the max speed, so we are not going to accelerate. Then we are calling again, and we are going to accelerate by 10 units. We are saying that, okay, accelerating current speed is 60 because 10 plus that 50 is 60 now. Then we are going to break. So the by 30 units. So 60 was the previous current speed minus 30. The result will be 30. Then finally, we would like to break by 200 units, which is larger than what we want. So it is going to show this message, car stopped. Actually, this is how we can modify private attributes using different functions here in Python. We could also use the get speed in the meantime when we were calling for example, we could here say print and then car1.get speed. So this way we were calling the get speed function. Like, let me show a message here as well. So the current speed of the Tesla. So if I print this several times, we can see the progress of increasing or reducing the speed. So here it says the current speed is 50. Then we are accelerating, the current speed is 60. Again, the current speed is 60. We are braking, the current speed is 30, and then the car stopped. So this is the correct way to access the private attributes to have their value being printed in the output. In this example, we learned how to work with public and private attributes because the brand was public, and we modified also the private attributes that was the current speed. By accelerating or braking, we modify the value of the current speed. Thank you for watching. Hi, welcome to this section. In this section, we're going to talk about inheritance in Python. So, what is inheritance? Inheritance allows a class to inherit attributes and functions from another class. It is a fundamental concept in object-oriented programming that allows a class, let's say a child class, to inherit attributes and functions from another class that could be a parent class. Okay, this is very useful method because this promotes code reusability and helps in building hierarchical relationship between classes. So you don't have to write down one function many times in different classes. You can have a parent class where you define your function, and you can have a child class that are inheriting from the main or base class, let's say, and they can access the attributes of the base class, they can access the functions of the base class. So we don't have to redefine these functions and attributes in the child class. Okay, so instead of writing the same code multiple times, we define common properties and behaviors in a parent class and let child classes inherit them. So in this section, we're going to dive deep into the inheritance concept in Python. Stay tuned. Hi, welcome back. So there are different types of inheritance. We're going to start by single inheritance in this video. We are having a class called animal, and this animal class has one function only. And the function name is sound1. Whenever this sound1 function is called, it is going to print this message. Animal makes a sound. Okay? Then we are having a dog class that inherits from the animal class. In order to show that a class inherits from another class, we write down the keyword of class, then we type down the name of our current class, let's say the child, then we are in parentheses mentioning the, for example, the parent class. Okay, so here the dog class inherits from the animal class. This is how we can show it in Python. So in this dog class, we are having a function called sound2, and whenever this sound2 function is called, this message is shown in the output. Dog barks. Okay? Now, I would like to create an object from the dog class. So we write down the object name. I call it d equals dog, an empty parenthesis, because we have no arguments to pass because we have no constructor here. Then using that object, I call the sound2 function. When I call the sound2 function, it is going to show this message to me in the output. Dog barks. Okay? This is printed in the output. However, because the dog class inherits from the animal class, using an object of the dog class, I can have access to the sound1 function as well. So I write down the name of my object, which is d.sound1. And when I run the code, I see that this animal makes a sound message is shown in the output. So one thing that we learned in this video, if a class inherits from another class, okay, let's say the child class inherits from the parent class, I can create an object from the child class and use that object, to call the functions of the parent class. This is what we learned so far. But what if the name of these two functions are the same? So we are having a parent class that has a function called sound, and we are having a child class that has a function called sound again. So in this case, when I have two functions in two classes that are having the same name and one function inherits from another function, when I create an object of the child class and I try to call the sound function, it will indeed call this sound function and not this one. Okay, so when I run this code, we see that dog barks is shown in the output. So this is the second point that we need to learn about single inheritance. If the parent class and the child class both are having functions that are having the identical names, we are creating an object of the child class. Through that object, we can only access the function that is inside the child class if both names of the functions are the same in the child and parent class. Okay. However, if the functions are not the same and there are different names here, for example, using the object of the child class, we can have access to both of the functions thanks to inheritance. So this was a very good example to understand the basic concepts of single inheritance in Python. In the following videos, we are going to talk about different types of inheritance in Python. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about multiple inheritance in Python. We would like to write a program that defines two parent classes called father and mother and a child class called child that inherits from both of the parent classes. Here is my first parent class called father. This class has one function called showFather. Whenever this function is called, we are having this message being shown in the output, father's property. Then we are having the second parent class called mother. Then this has a function that is called show underscore mother. And whenever this function is called, we're going to have this message in the output, mother's property. Finally, we are having a class called child that inherits from both of the classes. So here, first of all, we learn that the child class can inherit from first parent class, comma, second parent class. Okay, so it's possible for a child class to inherit from two classes, or let's say multiple classes. This is how we can declare them. Then we are having a function called showChild, and whenever this showChild function is called, this message is shown in the output, child's property. So here we are creating an object from the child class. By using that object, we can access the showFather function, then showMother function, and also the showChild function. So let me run the code. When we run the code, we see these messages are printed in the output. We see that father's property, this print is shown, then mother's property, this print is shown. Sorry, father's property, this print is shown, then mother's property, this print is shown, then child's property, which is this print for us. So in this video, we learned how a child class can inherit from multiple classes and how an object of the child class can access the functions of both parent classes in Python. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about multi-level inheritance. We're going to write a program that demonstrates multi-level inheritance, where animal is the base class, mammal is a derived class, and dog is a further derived class. Let me illustrate it with an example. Here is the base class, or let's say the parent class, called animal. It has one function called speak, and whenever the speak function is called,
we're going to have this message in the output being printed: animals make sounds. Then we are having the child class, or let's say the derived class called mammal, inheriting from the animal class. And it has one function. And whenever this function called has fur is called, this message is going to be shown in the output. Mammals usually have fur. Then we are having another class called dog that inherits from mammal. So we are having one animal class, we are having a mammal class inheriting from animal class, and we are having a dog class inheriting from mammal class. This is what we call multi-level inheritance. The dog class has a function called sound, and whenever the sound function is called, we are going to have this message shown in the output: dog barks. Now we would like to create an object from the dog class, okay, called D. Then using that object, we would like to access the speak function in the base class, then the has fur function in the base class for the dog class, then the sound function in the dog class, because dog inherits from mammal and mammal inherit from animal. So indirectly, dog inherits from animal as well. Therefore, using an object of the dog class make it possible for us to access the speak function and also the has fur function, and of course the sound function. So when I run this code, we see these outputs. We see that when the speak function is called, animals make sounds message is printed in the output. Then we are calling the has fur function, and we see that mammals usually have fur message is shown. And finally, when the sound function is called, this message dog barks is shown in the output. This is how we can manage to have multi-level inheritance in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about hierarchical inheritance. So multiple child classes inherit from a single parent class. We're going to write a program where multiple classes, we call them dog and cat in this example, inherit from a common parent class called animal. So here is the parent class. It has a function called sound, and animals make sounds. Message is going to be shown in the output whenever this function is called. The dog class is inheriting from the animal class. It has the same name function called sound, and this message is shown whenever the sound function is called dog barks. And also we are having the second child class inheriting from the animal parent class, and again the same name for the function sound, and this message is shown cat mews. Okay, so now we are creating objects, one from the dog class and one from the cat class. When we call the sound functions using the dog object and the cat object, we are going to call the sound in the dog class and also the sound in the cat class. Let me say it one more time. So I create an object called D from the dog class, and I use that object to call the sound function. When I use the D object to call the sound function, this sound function is going to be called. Why? Because the D is created from the dog class. So this sound function is called. And also, I then create an object called C from the cat class, and using that object, when I call the sound function, this sound function is going to be called because it is from the cat class and I'm using an object of the cat class. So when I run the code, we see that this message is shown first dog barks because we call the sound function in the dog class. Then cat mews is this sound function because we use the cat object to call the sound function. So this is how we can have hierarchical inheritance in Python, where multiple child classes inherit from a single parent class. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about hybrid inheritance. Hybrid inheritance is a combination of different types of inheritance. Here we would like to write a program that demonstrates hybrid inheritance using a person, employee, manager, and engineer class structure. Here is my base class called person. It has one function that is called show. Whenever this show function is called, we are going to have this message: I am a person. Then we are having another class called employee that is going to inherit from the person class. And this has one function as well, show employee. Whenever this function is called, I am an employee message is shown in the output. Then we are having another class called manager, and this manager class inherits from the employee class and not from the person class. Okay. So whenever it has one function called show manager, whenever this show manager function is called, I am a manager is printed in the output. Finally, we are having another class called engineer that also inherits from the employee class. So we are having four classes. The first one is the base class, then employee inherits from the person, manager inherits from employee, and engineer inherits from employee as well. In the engineer class, we are having a function called show engineer, and I'm an engineer message is shown whenever it is called. Then we would like to start creating our objects. I am creating an object from the manager class, from this class, and then an object from the engineer class. Okay, so one object from the manager class and one object from the engineer class. Then I use this manager object M to access show employee and show managers function. So the manager object is trying to access the show function, show employee, and show manager functions. How? Because we are creating an object of the manager class. So the object of this class, of course, has access to this function because this function is defined inside the manager class. Then because manager class inherits from employee and employee inherits from person, the object of the manager can have access to show employee and also the show functions. So we are going to have I am a person, I am an employee, and I'm a manager messages shown in the output using the object of the manager class. Then using the object of the engineer class, we are going to access the show engineer function, show employee function, and show. Why? Because we are creating an object from the engineer class. So of course we can have access to the show engineer function because it's a function defined inside this class. Then it can access the show employee because engineer inherits from employee, so it can have access to show employee function. And also it can have access to show function because employee also inherits from person class. Therefore, the object of the engineer class can access to this function, and this function. So whenever these three functions are called, we are having these messages: I'm a person, I'm an employee, and I'm an engineer in the output. When we run the code, exactly we see what we expected. I'm a person, I'm an employee, I'm a manager using the manager object, manager class object. Then using the engineer object, we are having these three messages. I'm a person, I'm an employee, and I'm an engineer. So we see that we could have a hybrid inheritance, and using the objects, we could have access to different functions. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about a keyword called super in calling parent class method. So the super function allows access to the parent class function inside the child class. Let me illustrate it with an example. Write a program that demonstrates how to use super function or super method to call a parent class method or function inside a child class. Here is my parent class called animal. We are having a function called sound. And whenever the sound function is called, this message is printed in the output. Animal makes a sound. And we are having a child class called dog that inherits from the animal class. We are having a function called sound, and whenever this sound is called, this message is shown in the output. Dog barks. Afterwards, we are creating an object from the dog class. Then we use that object to call the sound function. So when I run this code, we see that dog barks is shown in the output. But what if I would like to also call this sound function from the parent class, that they are having the same name? When they are having the same name, when I use the object of the child class, this sound function is called. There is a solution for that. In order to call this sound function inside the parent class, we can use the super function. So we type down simply the super keyword with empty parentheses, then dot, then the name of the function in the parent class. So whenever this function is called, we are going to first call the sound function in the parent class and print the animal makes a sound message in the output. When the call of this sound function is finished and everything in that function is executed, the compiler finishes this line and goes to this line, and it is going to print dog barks. Let me run the code. Now, when I run the code, here we see exactly the same thing. So I created an object from the dog class. I use that object to call the sound function. Still, this sound function is being called. Whenever this sound function is called, the first thing that is going to be implemented in this function is the super function that is calling the sound function from the animal class. Okay, now we are here. The compiler goes here, call this function, and print this message. Animal makes a sound. This is why we are having it in the output. Then when the execution of this function is finished, it comes back here, it goes to next line and prints dog barks. So in this video, we learned how we can use the super method, or let's say the super function, in the child class in order to call the function in the parent class that has the same name as the function that we have in the child class. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about method resolution order in multiple inheritance. We would like to write a program that demonstrates method resolution order using multiple inheritance. Imagine that we are having class A. One function is called show, and whenever this function is called, the class A message is shown in the output. Then we are having a class B inheriting from A, and it shows, it has a show function again, and it prints class B whenever this show function is called. Then we are having a class C, again inheriting from A, and it has the same name function again, and it prints class C in the output whenever it is called. Finally, we are having a class called D that inherits from both B and C. So it's a multiple inheritance for this one. Then we are having a keyword pass. So we don't want to do anything in the class. In order to say that to Python, we write down the pass keyword. Just do nothing inside D. Then we are creating an object from the class D here. Okay, here is my object called D from the D class. Then I call the function show. And we see that we have no function called show in the D class. Now, you think that which one of these show functions are printed in the output? So when I run this code, we see that class B is printed in the output. So this function show is called. When I call the show function using the object of the class D, because D has no function called show, this function is called class B. And why not class C? And why not class A? So here is the logic. The class D inherits from B and C, and Python follows method resolution order using the linearization, okay? So we are going to go from left to right rule. Therefore, D inherits from B and C. And Python looks for the function show in D, and D doesn't define it, so D doesn't have it, and we wrote that pass, just do nothing in D. Therefore, it follows the method resolution order, which is this one. So this is D. It checks for the function show. It does not find it. So it goes for B. It goes for class B. Then it goes for class C. Then it goes for class A. Okay, so and because the function follows the method resolution order, from left to right, a rule is defined in Python. So left to right priority, let's say. Here, because first it inherits from B and then C, so class D has the show function? No, it does not have it. So it follows this left to right priority. It checks the class B. Class B, does it have the show function? Yes, it has. So it is the first time that it finds the show function, and it is inside the class B. So it executes this show function that is going to help us to print class B message. Let me illustrate it one more time. So Python follows the method resolution order. It means that from depth to first or from left to right rule. So from left to right has priority. First, we are creating an object of the class D, and we call the show function. So the Python starts searching in class D to see if it finds a function called show in class D. And we have no function called show. Therefore, it is going to go for class B because it's on the left side. It is more on the left compared to C. So it is going to go to class B. And then C, and then A. Okay? B, then C, and then A. Okay? So it checks to see if it finds anything in class B that has a function called show. So it checks class B, it sees that, okay, there is a function called show, and it prints the class B because it calls this function. And then the program is terminated. So I type down the method resolution order steps here using this line so you can see it in the output. So when I run the code, we see the class B message in the output. Then we see this is how Python goes. So it starts from class D, then goes to class B, then goes to class C, and finally goes to class A, exactly as we explained here. So from left to right. One more time. We start from class D, we find the show function. No, we don't find it. So we go for the next class, then next class, and then next class. So after D, we go for B, C, and A. But when checking the class B, we see that there is a function called show. Therefore, we are going to call that function, and when that function is called, the class B message is shown in the output. This is how actually this program works and this program executed. This is called method resolution order in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about default arguments. We would like to write a program where a function can handle different numbers of arguments. Here we are having a class called Matplotlib. Inside this class, we are defining a function called add. And this add function has 3 arguments as you see here, apart from self. Argument A, argument B, and argument C. So here, this function, when it is called, it is going to add A plus B plus C. So A added to B added to C. So it is going to calculate this and return the output for us. But what does it mean that we are having C equals 0 in the arguments in our add function? We never had that before. So this is the default argument. So if I call this function and use 2 arguments, which are A and B, then by default, it is going to assign number 0 to be argument C. Okay? But if I call this function with 3 arguments, the third argument is going to replace that 0. Let me illustrate it with an example. Here we are creating an object from the math operations class, and using that object, which is called math, we're calling the add function. So math.add. Then here we are having 2 arguments, 5 and 3. So 5 is for A and 3 is for B. So when I call this function with these 2 arguments, although it requires 3 arguments here, it is going to consider A equal to 5, B equals to 3, and C equals to 0 by default when we have no third argument. Therefore, it is going to calculate 5 plus 3, so the output is 8. As you see here, when we run the code, we see 8 here. However, if I call the very same function, but this time we have 3 arguments instead of 2. Here A equals 5, B equals 3, and C equals 2 this time. So when we have a third argument, this third argument is going to be assigned to a variable or argument or parameter C, let's say. Then it is going to return 5 plus 3 plus 2. So this is what's going to happen. So what we learned from the default argument is the following. If we are having, for example, a function like this add, and it has 3 arguments, A, B, and C equals 0, it means that we are having the third argument as a default argument. Therefore, it is possible for us to call the function only using the first 2 arguments, A and B. This is why when we call the function with 5 and 3, it works and it gives us the output. However, if I call the function using 3 arguments like 5, 3, and 2, that last argument is going to be replaced this 0, okay, and C will be equal to the last argument, which is 2, and then it is going to calculate A plus B plus C. This is how we can work with default arguments in Python. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about polymorphism. Polymorphism means many forms. In Python, polymorphism allows different classes to define the same method name, but with different implementations. Why do we need to use polymorphism? It helps us to use our code in a better way, so it improves our code actually. It promotes code reusability, in other words. It supports flexibility in program design, allows different objects to be treated uniformly. And there are different types of polymorphism in Python. The first one of which is method overriding, or let's say runtime polymorphism. The second one is method overloading, meaning that you can use default arguments. And in the third one, it's operator overloading. The fourth one is polymorphism with functions and objects. Then we discuss polymorphism with abstract classes, and finally we talk about doc typing. So these are the main topics in Python that we can discuss polymorphism. In this section, we're going to dive deeper into the concept of polymorphism and go through all these methods one by one, all these types of polymorphism, one by one, and provide coding exercises. Thank you for watching. Hi, welcome back. In today's video, we would like to write a program that demonstrates method overriding in a parent vehicle class and child classes car and bike. So we discussed that there are different types of polymorphism. In this video, we are going to have a coding exercise in which we are working with overriding. Here is our class called vehicle. It has a function called start. And whenever this start function is called, we are going to show this message, starting the vehicle. Okay? Then we are having another class called car, which is a child of the vehicle class, or we can say it is derived from the vehicle class. And it also has a function called start. And whenever this start function is called, we are going to have this message, car starts with a key. Okay? And finally, we are having the third class called bike, which is derived from the vehicle class. It has a function called start again, and it is going to print bike starts with a button. Okay? So as you see, these two classes are derived from the vehicle class. So the vehicle class is our base class, or let's say parent class. And each of these classes are having a function with the same name. Actually, this means we are overriding the parent class because the parent class has a function called start, but the child class has a function with the same name. And I would like to now create an object of these two children's, okay? The V1, which is my first object, is created from the class called car, and the V2 object is created from the class bike, okay? Then we would like to use these two objects to call the start function. But which start function is going to be called in this situation when we are having overriding? Okay, when we are having overriding and we are creating an object from the car class, and when we use that object from the car class to call a start function, this start function is going to be called and not the parent one. And this is overriding. actually, because we are having a child class derived from the parent class, and they're having a function that they are having the same name, identical names. Therefore, overriding means you have uh, the two functions with the same name. So we are overriding the main function that is inside the parent class. Okay. So here I use the object of the car class and I call the start function, and we expect that this car starts with a key message is going to be printed. Then I use the second object to call the start function again, and here we know that v2 was created from the bike class, and when we use that object and we call this function, we expect to have this in the output. Bike starts with a button. So when I run this code, we see car starts with a key message is shown in the output, which is this one from the car class, which is derived from the vehicle class. And also then this bike starts with a button message is shown because it is the print of the start function, from the bike class, which itself is derived from the vehicle class. So this is how we can implement overriding method in Python, that we have a parent class and, for example, two children classes, and inside the children classes we are having functions with the same name as the parent class function. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about overloading a function to calculate area. Here we are having a class called shape. In this shape class, we are having only one function. This is my function called area. It requires two arguments, length and breadth, apart from self. And we are putting breadth equals to none. And then if breadth is none, this is the if condition. We are defaulting this argument, okay? And now we're saying if breadth is none, then return the output of length multiplied by length itself. And we realize that our shape is a square. Otherwise, if the breadth is not none, come to this else part and return length multiplied by breadth. And it means that our shape is a rectangle. But what does it mean? We would like to overload this function. So if we call this area function and we pass only one argument, it will be the length argument. And in that situation, the compiler is going to, by default, consider breadth to be none. And here we are checking, okay, now that breadth is none, multiply length by itself. Okay, so it's a square. However, if we called this area function with two arguments, the first one is length, and assign the second one for the breadth, and then you check breadth is not no, because there is a number assigned to it, because we had an argument about that when we called the function. Therefore, come to this else part and multiply length by breadth. Okay, let me illustrate it with an example. It will be easier. So we are creating an object of the shape class here. I call the object S. Then I'm calling the function saying that area of a square, and I use the object s.area, the name of the function, and in parentheses I write down number 5. So I'm having one argument only. When I call this area function, the compiler runs this area function and it has one argument only. So length equals 5 and we have no other arguments. Therefore, breadth is by default assigned to none. And because it is assigned to none, we check it here. Breadth is none. Is it true? Yes, this statement is true. Therefore, return us this value, length multiplied by length. So 5 multiplied by 5 is 25. It is returned here. It is returned. And then because we are inside the print function, it is going to print 25 for us. Then I try to call the function one more time. I mentioned this message, area of rectangle. Then I call the area function. This time I'm having 2 arguments. So the 5 equals length and the breadth equals 10 this time and not none. Okay, it will be equal to none only if we have no argument provided for that. So if I call the function with 1 argument, it means that breadth is assigned to none by default because we are putting it there. However, if we have the call of the function with 2 arguments, the second argument, which is 10, is going to be assigned to the breadth, and then we check if breadth equals none. No, this statement is not true because we assign number 10 to it. Then, okay, go to this else part and return length multiplied by breadth, which means that 5 multiplied by 10. So when I run this code, we see the output here. It says area of a square, and then 25 is printed. Then area of rectangle, then number 50 is printed here in the output. Actually, this is a very good example of learning how overloading a function for calculating the area of different shapes would work in Python, and how in fact they are being implemented in Python easily. Thank you for watching.
Hi, welcome back. In today's video, we are going to do another coding exercise about overloading. Here we are having a class called printer. In this class, we are having a function called display. So this is the only function of our printer class. This function requires 2 arguments, text and number. A number by default is assigned to none. So now we are going to do certain things in this function, but we're going to get back to this function later. But let me explain this function through an example. Here we are creating an object from the printer class. I use that to call the display function, and I am having only 1 argument called hello. When I go up, this function is called with 1 argument, which is hello. So this is assigned to text. A number is by default assigned to none. And here we are checking to see if number is none. If it's true, which is the case, we are going to enter this if condition, and this part is going to be checked now. And here we are checking to see if the variable text is of string type. Is it? Yes, because we are having a string here. So if this is true, print the text for me in the output. So hello is going to be printed. Let me repeat it. We call the display function, and we are having only 1 argument. This argument is assigned to text, and the second argument is having a default value, which is called number, and number is assigned to none by default. Then we check if number is none. In this case, the number is none because we are having only 1 argument, and that is assigned to text. So the default value for number remains the same. And we check, okay, if number is none, yes, then it enters this part. And then we need to have the checking of this if condition. We check if this text variable is of type string here in this line. Okay. Then if this is true, we are going to print hello. Otherwise, if it was not true, we were going to print the number. Let me call the display function with another argument. So now I call the display function one more time, and this time I'm having the argument as a number and not a string. It's 100, the argument. So this display is called, display function is called, And now, because we are having only, again, one argument, this 100 is assigned to this argument, this parameter here, text, and not this one. This one will be activated only if we have two arguments, because it is the second argument, okay? Don't get confused that the name of the parameter is number. So this is the second argument, and if we were having a second argument, that second argument would have been assigned to the number parameter here. We are having only one argument, and the argument is going to be assigned to text. Here we are checking if number is none. Yes, number is still none because we didn't have a second argument. Then we are going to enter this part, and we are checking this if condition. Now we are going to check if this text parameter or variable, let's say, is of type string. Is it true? No, this time it's not true because it's 100 is not a string, it's a number. Because this condition is not true, then this part is not going to be executed, and the else part is going to be executed, and we are going to print number message, and then the number 100 is going to be printed in the output. Now, what happens if we are having two arguments? If we are having two arguments, is my example here. So hello and 100. We're calling the display function. Hello is assigned to text, and 100 this time is assigned to variable called number, because here it is the second argument. We check if number is none. No, number is not none anymore. None was the default value. This time it is 100. So it directly comes here to this else part, and it says text hello number 100. So when I run this code, we see exactly the same thing as we discussed here. We can see that in the first time when we are having only one string, the hello text is being printed. So text is assigned, this hello is assigned to text. Number is none, yes. So is it a string? Yes. Therefore, type down text and then hello. This is text and then hello, okay? Then we call the display function with 100. 100 is assigned to text. Number is none. Yes, it is still none. The text variable is holding a string. No, then go to this else part and print number, which is 100, number 100, okay? And finally, call the function with two arguments here, and hello is assigned to text, 100 is assigned to number. Check if number is none. No, it's not true. Then it goes to the else part, and it says text hello and number 100. So this is basically how we can have an overloading method in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about operator overloading. So operator overloading allows us to redefine how operator likes addition, subtraction, multiplication, and division work for custom objects. In simple words, it allows objects of a class to use operator just like the built-in data type, numbers, strings, for example. So for example, here 2 plus 2 equals 4, okay? Operator overloading allows me to have two objects, for example, object 1 and object 2, to add these two. So object 3 equals object 1 plus object 2. So the operator overloading is this concept. So we can use these operators for objects, okay? So in order to illustrate it with an example, here is my class called money. It has a constructor, and whenever we create an object of the money class, that argument for this constructor is assigned to the attribute of this constructor, self.amount. Okay, so it is initializing our attributes, in fact. Then we are having two overloaded functions here. So the first one is overloaded add, and the second one is overloaded str. Okay. So using this overloaded add, we can add two objects, and using this overloaded str, we convert the object to a string for printing. Let me illustrate it with this example. Here I create the first object called wallet1, and it is from the money class, and we are having this number. Okay, so the amount is 50, and amount is assigned to our attribute here. Okay, so we are initializing our attribute for the first object. Then we do the same for the second object. However, the amount is 30. So the first one was 50 and the second one is 30. Now we would like to create the third object, which is the wallet1 plus wallet2. So thanks to operator overloading, we can do that. Otherwise, it's not possible to do that. So when we are having wallet1 plus wallet2, automatically the compiler is going to use the overloaded add, then have this self.amount plus other.amount. Okay, so the self and other. So two operators, two values for two different objects are being added to each other, and it is going to return that for us and assign to wallet3. So for example, if I remove this part and I compile, we see that there is an error. Okay, there is an error here. So we cannot do that. It says unsupported type for plus money and money. Okay, so it's not possible to do that because we cannot add two objects to each other unless we are having the operator overloading. So this will help us to add the value of these two objects and assign it to wallet3 objects. Okay, so this is how the operator overloading works with the add, for example, overloaded add. Then in order to convert the output of this wallet3, we need this overloaded str. So when I run the code now, the overloaded add is there. When I run the code, we see that 80 is shown in the output. Okay, so this 80 is shown in the output, and the dollar sign comes from here that we are having it here. So dollar sign and then self.amount is being printed for the value of wallet3. But if I also remove this part and recompile, we are printing the memory address of this object wallet3. You see? So it is the memory address that it is stored, but we need to convert this object to a string so we can see what is the value that this object is holding. So when I have the overloaded str, it's going to help me to see actually its value. And basically this overloaded str is returning simply the dollar value, the dollar sign, sorry, because we are talking about dollars here. And then we are simply typing down self.amount, so the attribute that is assigned to wallet3, which is the wallet1 plus wallet2 from the overloaded add, is going to be shown in the terminal. So this is how actually we can use operator overloading to add the two objects to each other to assign to the third object, for example. And there are different operator overloading. There are subtraction, multiplication, division, equal, larger than, lower than, etc. We try to cover some of them in the following videos for your practice. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about operator overloading. So we would like to add, for example, two objects to each other. Basically, it's not possible to do it unless we're using operator overloading. Here we're having different operator overloading in this coding exercise. Here is my class called box. Here is my constructor, which is going to assign the argument as my attribute here. We are having overloaded add, that it is going to add two items or let's say two objects. We are having the mul, overloaded mul or mul, that we are going to use for the multiplication. Then we are having the gt, overloaded gt or greater than, let's say, to compare if one item is larger than the other. And it's going to give us the result as the true or false. Then we are having the overloaded str to show the to convert the object into a string so we can show it in the output. Here we are creating object box1 and object box2 from the box class, and we are assigning two numbers, 10 and 20. So 10 and 20 are initialized and assigned to our attributes for box1 and box2. Now we would like to use overloaded add. So we have the box3 equals box1 plus box2, and we are printing box3. Basically, we expect to have 10 plus 20, so the output will be 30 here. So when I run this code, I see box with 30 items is shown in the output. Then we are having the call for the multiplication. So overloaded mul is going to be called. Here we are having the box4 object equals box1 multiplied by 3. So whatever that is inside the box1, which we assign to be 10, for the attribute using the first object, we are going to multiply it by 3. So 10 was the argument that we assigned to initialize our attribute using the first object, box1. Now we are using the same object and multiply it by 3. And this is done through this overloaded mul. Basically, it is going to have the attribute multiplied by the number that is here, okay, in the mul, overloaded mul. Then we are going to print this box4, and for that we are going to use the str. We are saying that box with, and then the number is being printed, items. So here we expect to see also 30 because this one is 10 multiplied by 3. It will be 30. So box with 30 items. Finally, we would like to compare two boxes, box 1 and box 2. In order to compare, the compiler is going to use overloaded greater than or overloaded gt, and we are going to check if the first one is larger than the other. If it is true, it is going to return true. If this is not true, it is going to return false. So we are having box 2, which is 20, and box 1, which was assigned 10 for its attribute. So we are basically saying that 20 is larger than 10. Is it true? Yes. Therefore, we are having the true in the output. If it was not true, we were going to have the false result in the output. So in this coding exercise, we learned to work with a few of operator overloadings in Python. We have a constructor here that is assigning our parameter to our attribute. Then we are having overloaded add. So two objects are being added. Then we are having overloaded mul. So the value of the attribute stored using one object is multiplied by a number, for example. Then we are having the greater than overloaded, where we compare to the value that is stored using two objects, okay, to see if the first one, for example, is larger than the second one or not. So we are going to have the result of output as the true or false. Then finally, we again have this str to convert the object into strings so we can have these beautiful messages in the output. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about polymorphism with functions and objects. Here is my class called dog. And then inside this class, we are having a function called sound. And whenever this sound function is called, this message is going to be printed. dog barks. Okay. Then we are having another class called cat, and whenever this function sound is called that is inside the cat class, this message is shown, cat mews. So this is the cat class. Inside that we are having only one function again called sound. And then when this sound is called, this sound function is called cat mews, message is going to be printed in the output. Okay. Then we are having a polymorphic function that is going to work with different objects that we call animal here, for example. Okay. And using that object, we are going to call the corresponding sound function. So sound function was something in the dog class and the cat class. Okay, but how can we work with this polymorphic function? Let me illustrate it with an example. Here, I'm having a list of different animal objects. Okay, so a list containing instances of dog and cat, our classes. Okay, so here before that we were having, for example, animals equals the name of the name of the class and then empty parentheses. Okay, this is how we can use we can create an object of the dog class. But here we are having the same name, but it's a list containing objects of two classes, dog and cat. Okay, so it's a list of objects, or let's say instances of dog class and cat class. Okay, then we are going to iterate through this list. In order to iterate, we are having a for loop. So we are saying our iterating variable is called animal, let's say. And we are saying for each animal inside this animals list, just call the make sound function and pass the object, the animal. Okay. So let me illustrate it here. We are going to loop over this list, and it has two objects inside of it. So basically what we are going to do, we are going to have the make sound function to be called. The first time the make sound function is called, and inside parentheses we are going to have the animal. And this animal is the object that created from the dog class in the first iteration, because the first element in this list is relevant to the dog class. And then we are going to call the make sound function again with our iterating variable that is called animal, but this time animal equals the cat. So it is like this. So animal equal dog. And here it's like animal equal cat. Okay. So we are iterating through this list. It has two elements. In the first iteration, we are calling the make sound function with the animal object, and the animal object in the first iteration is declared like this to be an object of the dog class. In the second iteration, it is an object of the cat class. So when we call this function, what happens? We're calling this function and passing the object. And that object is used to call the sound function. So in the first iteration, because animal is an object of the dog class, we are having animal.sound. Therefore, this sound function is called, which is from the dog class. And in the second iteration, animal object is from the cat class. When we call the make sound function, we are passing that animal object from the cat class. And then we are using that object to call the sound function, which is inside the cat class this time, because we are using an object of the cat class. So cat mews is shown in the output. So when I run this code, we see dog barks and cat mews. Okay, so firstly, this function is called as we expected and explained, and secondly, this function is called and this message is printed in the output. So this is how actually in Python we can work with polymorphism with functions and objects. So let me review it one more time. We have a class called dog. It has a function called sound. Whenever this sound function is called, this message is being printed, dog barks. And we are having another class called cat. It has the same function name. And whenever this sound function is called, this message is printed in the output, cat mews. Then we are defining a polymorphic function that works with different objects, okay? But before diving into this function, we are going to talk about what we do here. So we are creating a list of different objects of the dog and the cat classes. And then we are iterating through that list of objects. So for each animal in this list, we are calling the make sound function and pass the object as argument. So in the first iteration, we are going to have like initializing an object like this. So animal equals dog, which is the way that we were using so far to create an object. So animal is now an object of the dog class, and this animal is used to call the make sound function. So make sound function is called, and that animal, which is an object of the dog class, is passed. So we are using that object to call the sound function, which is this function, and dog barks is printed in the output because whenever the sound function is called, dog barks message is shown in the output. Then we are having the second iteration where animal equals the cat. It means that we are creating an object from the cat class, and then we are passing it to this make sound function, and we are using the object of the cat class to call the sound function, which is this function, and it says cat mews. Okay, and this message is shown in the output. So this is how actually we can work with polymorphic functions and also having polymorphism with functions and objects. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about doc typing. Here is my class called car. It has a function called start, and this function is going to print car starts with a key. Then we are having a class called bike, and it has also a function called start, and it prints bike starts with a button. Then we are defining a polymorphic function that works with any object having a start method. Okay? Because inside this function, the argument is an object, and basically using that object, we are calling the start functions, okay, in different classes. Now we would like to create an object. In order to create an object, we can do it like this. So this way, we are directly calling the start vehicle function with an object of the car class, and this way we are calling the start vehicle function with an object of bike class. Basically this part, car with empty parentheses, this creates an object of the car class. It's the same as this one. Okay, it's the same as this one. Car underscore object equals car. So we used to create an object like this, but using it here, it's exactly as the same as this one. So we are creating an object of the car class, and then we pass that as argument for the function start vehicle. So the start vehicle function is called with that object as argument. We are going to use that object to call the start function. So because the first argument is from the car class, this start is going to be called car starts with a key. So this message is shown in the output. Then we are creating an object of the bike class for the argument, and we call the start vehicle function. And in this function, again, we are going to use that object of the bike class to call the start function, which will be this start function this time because we're using an object of this class. And it shows this message: bike starts with a button. So this message is printed in the output. This is how we can actually change the way that we are creating an instance or an object from a class, and this is how a polymorphic function work with any object that have a function called start inside that class. Thank you for watching.